Okay, this is a video associated with Unit 5, Activity 3, which is perimeter and area of composite shapes. Composite shapes are when I take different basic shapes and combine them to make a shape that doesn't necessarily have a name in geometry. So for example, a running track is a composite shape. It combines rectangle with two semicircles. And I don't think there's a name for the shape of a running track, although if there is, you can always let me know down below in the comments. We've got a standard running track is 400 meters. That's an Olympic-sized track. I think a lot of high schools in London have that track, which includes 100-meter straightaways and then curves. I don't exactly know if this track is going to have a 400-meter perimeter or outside. What we're going to find out in this problem. I haven't actually done it before. So the first question asks us to find the perimeter of the track or running around the outside. So I'm not sure if they mean running in lane 1, so really close to the infield. So if you think about if this track was at your school, this inside would probably all be grass where we play soccer or football, and then the outside is some sort of cinder block or synthetic surface or dirt where people would run around. So if we run in lane 1, we'd run the shortest distance, and we'd just be going around the outside of the infield. Or I don't know if it means running around the outside, like running along the farthest lane, which sometimes would be lane 6, depending on how big the track is. That's going to be a longer distance, right? So why don't we actually just do both? Because I'm not sure what the question is asking. So we're going to find the lane 1 distance. So if I hug the rail or the inside of the track, how far do I run? Or if I go around the full outside of the track, how would I go? So we're going to call that our lane 6 distance if it's a 6-lane track. I'm not sure. So in other words, we're going to find the perimeter of this inside composite shape and the perimeter of the outside. So the perimeter means we need to add up all of the sides. So perimeter is always the sum of the sides. So in this case, I've got the two straightaways, 100 meters plus 100 meters. But then I've also got these two curves, which each are a semicircle. So semicircle, well, we know a circle is going to be pi times diameter. So of the inside of the small shape, that's going to be pi times 28.5. And then it's a semicircle, so I'm going to divide it by 2. But then I've got two semicircles, so I've also want to multiply that by 2. So it turns out I'm just finding the perimeter of a circle. So that's going to give me the perimeter of the track. So it's going to be 200 plus 3.14 times 28.5. You could also use the pi button, but 3.14 is sufficient for this course. Not all calculators would have a pi button, or you might be doing this by hand. Okay, so this track is actually not your kind of full 400-meter track. I'm actually only going to be running 289.49 meters. So that would be the distance. If I ran the whole race in lane 1, I would only have to run 289 meters. What if I, for some reason, was running on the outside of the track? How much more would I have to run? Well, again, it's going to be 100 plus 100. The straightaway there is the same, regardless of what lane I'm in. But now the outside diameter is this whole distance, 32.5. So I'll do pi times 32.5. And again, because I have two semicircles, that's the same as finding the circumference of just one circle. So it's pi times diameter. So I've got 200, and this time it's pi. So we'll do 3.14. There was a bit of glare on my calculator today, times 32.5. So I've got to travel, whoops, there goes my calculator, an additional 102.05 meters. So I have to run 302 meters. I'm actually running quite a bit more. I'm running around 12 and a half more meters each lap of the track. So that could make a difference, especially in a longer race. So that's why we should always hug the rail of a track. The second question was, let's find the area of the track surface. So when I say the track surface, the question doesn't want to know the area of the inside field. I only want to know this area all the way around the outside of the track. So I only want to know that part of the track that maybe is cinder blocks, crushed cinder block, or dirt, or Now it's a synthetic rubberized surface often in professional tracks. So we want to find the area of the track surface. So the way I'm going to do this, I'm going to find the area of the larger outside track shape and then subtract the area of the inside. So the first thing I'm going to do is find, let's just call it A big, and remember we can use subscripts to label. And then we're also going to find A small. So to find the area of composite shapes, I want to break up the shapes. They're always kind of broken up nicely for me. So the area of that big one, well, I've got a big rectangle in the middle. Rectangle is just width times length, so I'm going to have 100 times 32.5. And I'm also going to have the area of those two semicircles, but because they're two semicircles put together, that's just the area of one circle. And we know the area of a circle is pi r squared. So I'm going to do 3.14. And the radius of the big circle, well, radius is half of diameter, so half of 32.5, 16.25 squared. And what I'm actually going to show you to do is that once I've got it all in one step, I can punch that all into my calculator at once to save me a little bit of work. So I'm going to do 100. And I know many of you have similar calculators where you're going to be able to put everything in one step. So I've got the rectangle and then plus that split up circle, so pi times radius, 16.25 squared. And that's going to give me the area of the big track, which is 4,079 meters squared. So that's the area of this entire shape. Now I'm going to find the area of this unshaded inside that's often in grass, and then I can subtract that to figure out just what the border is. So A small, well, that rectangle now is 100, right? The length is the same, the length of your straightaway. Let me refocus my page. But I've got now a width of only 28.5, and similarly my circle now has a smaller radius, right? So half of 28.5 is 14.25, and it's pi r squared. So again, if you want to put the formula in up top, I'm doing width times length plus pi r squared. And I had the exact same formula over here. So you might want to add that in to kind of show your work if you'd like. And again, I can do that all in one step in my calculator. Got to figure out a way to do the calculator part without so much glare. And again, if you want to use the pi button, that's fine, but 3.14 is always sufficiently precise for our course. So I've got 14.25 squared. So the area of that inside soccer field or football field is 3,487.6 meters squared. So then the area of the track, so why don't we call that A track, is that outside border, is going to be A big minus A small. So that's going to equal 4,079 minus 3,487.6. So the area of just the track surface will be 591.4 meters squared. So that's an example of composite shapes. To find the perimeter, you need to add up all of the outside sections. And to find area, you need to split the shape into multiple shapes that you know the formulas for to how to find the area, and then add them together. So this is smaller than a traditional high school track, but it might be, probably bigger than actually most elementary school tracks. Anyway, let me know if you have any questions, and if not, you can move on to some similar practice problems. Okay, that's all for now. Bye.